Hey everybody. I can't be with you today, so you're gonna watch the video. It's similar to what I'm gonna do in class, or what I would do in class. I'd like for you to make sure to take the notes down. So you have a new packet. We're gonna talk about, this whole unit is about triangle congruence. So we'll start reviewing triangle qualities, and then we'll move into proofs. All right, so again, make sure that you are taking these notes down. Okay, so first of all, we're going to talk about classifying triangles. So we're on page 2 in the new packet. Again, make sure you're taking the notes down. I'm going to be checking. There's 2 ways to classify the triangles. You can classify by the angle measure. So you look at the angle sizes. It's an acute triangle if it has 3 acute angles. If all the angles are the same, it's called equiangular triangle. So all 3 angles are the same. All the angles in a triangle add up to 180. So if you divide that by 3, that means that all of the angles are 60 degrees. So 3 congruent acute angles. Because all the angles are acute, it could also be considered an acute triangle. A right triangle has 1 right angle, and then an obtuse triangle has 1 obtuse angle. Okay, so those are your types of triangles based on angle measure. Side length, you're just looking at the length of each side. So you have equilateral, and any equilateral triangle is the same as an equiangular triangle. Okay, all the sides and all the angles are the same. An isosceles triangle has at least 2 congruent sides, and it also has 2 congruent angles, which are across the triangle from, those are supposed to be arrows, from the 2 congruent sides. Those are called base angles. We'll talk more about that later on, but just remember the 2 angles across from the 2 congruent sides are congruent. And finally, you have a scalene triangle that'll have no congruent sides. Okay, so let's look at a few examples. The first one, classify each triangle again by angle measure. So we're talking acute, obtuse, right, or equiangular. All right, so triangle DFG. So DFG, that's that whole angle. So we have angle measures of 54, 36, and 90. All right, because remember that square represents 90 degrees. So we have a right triangle. DEG, DEG. Well, right now we have the 54 and we have the 68. Since this whole thing is 90 and that's 32, if we do 90 minus 32, we'd find that this missing angle is 58. So we have angles of 54, 68, and 58. All of those are acute, so it's an acute triangle. Okay, in our last example, triangle EFG, EFG. All right, again, we have 36 and 32. If you notice, this is a linear pair, so that adds up to 180. 180 minus 68 is going to give us 112. So that makes that an obtuse triangle. Okay, turn the page. So classify each triangle in at least 2 different ways. At least means 2 or more ways, so there might be more than that. Okay, so the first one, we can tell that it's right because of that right angle. And we have 2 congruent sides, which means we have 2 congruent angles also. So that is isosceles. Okay, the next one, I can see this obtuse angle. So it's an obtuse triangle. And again, because of these markings right here, that tells me those are 2 congruent sides, which means that's also isosceles. And that would make these the same as well. Okay, all three of those sides on the next one have the same markings. So that would be equilateral. It would also mean that all the angles are the same. So it's equiangular. Equal sides, equal angles. And technically, because all of the angles are 60 degrees, they're all acute, that could also be considered an acute triangle. Okay, next one, if you look at all three angles, they're acute. And we have two congruent sides, and notice the angles across from them are also congruent. So we have another isosceles. Now, real quick, by definition of isosceles, it's at least two congruent sides. So this equilateral could also be considered isosceles because it does fit that description. All right, the last one, we have an obtuse angle. And all the sides are different, so it's scalene. Okay, a couple more questions with this. The perimeter of the triangle is 47. Classify the triangle according to side length. So we have a little work to do before we can determine the type of triangle. First, I'm going to start right here. The perimeter equals 47. When you want to find the perimeter, you add all the sides, right? Okay, well, let's do that. X plus 3 plus 2x plus 6 plus 3x plus 8 equals 47. All right, x and 2x, that's 3x, and 3x is 6x. Add up your numbers. 6 and 3 is 9, and 8 is 17. If I'm going too fast for you at all, that's the beauty of video. You can always pause it. All right, subtract the 17. Divide by 6. X is 5. Now it wants us to find out what type of triangle. So now let's plug it in and find the sizes of the lengths of our sides. So instead of x plus 3, 5 plus 3 is 8. Instead of 2 times x plus 6, 2 times 5 plus 6 is 16. And finally, instead of 3 times x plus 8, 3 times 5 plus 8 is 23. So there's your angle, your side lengths. They're all different, so that would make this scalene. We don't know anything about the angles, so you cannot say acute, obtuse, anything like that. Okay, next one, determine the value of x in the triangle. We cannot assume this is equilateral, but if you notice, here's two congruent angles. That means the sides across from them are also equal. We're dealing with an isosceles triangle. So I can say that the 3x minus 10 equals the 2x plus 10. We're not going to use the x plus 10 in the equation, all right? We're just using this one and this one because we know they're equal because it's isosceles. They're across from those base angles. Subtract your 2x. X minus 10 equals 10. Add 10 to both sides. X equals 20. And that's all it wanted us to find was the value of x. All right, so just look at the picture, look at the information they give you, and set up your equation from there. All right, one last thing I want to talk about, just a few angle relationships in triangles, and we'll do more with this tomorrow. The sum of the angles in a triangle is always 180 degrees. Now we're talking angles, not side lengths, all right? These don't add up to 180, all right? These don't add up to 180. Those are the sides. When we're talking about an angle, the angles in a triangle, they add up to 180. The angles of an equiangular triangle measure 60. We already talked about that. And the acute angles of a right triangle are complementary. So if you have a right triangle, that's 90. So these would also have to add up to 90 to make the whole thing 180. That's something that we'll worry about later on in the year. But for now, make sure you know the angles in a triangle add up to 180. Now, what if you have an angle outside of your triangle? That's called an exterior angle. And that's formed when one side of a triangle is extended. It forms a linear pair with the interior angle. So that means from here to here, those are going to add up to 180. Okay, that's a linear pair. I do have a shortcut that I'll share with you tomorrow in class, but for now, we're going to figure out these by looking at those relationships. So if I want to find x, I'm just going to take 180 and subtract 92. All right, so 180 minus 92 gives us 88 degrees. Okay, they're a linear pair. And then for y, all three angles in a triangle add up to 180. So if we take the 92 and 41 and add those up, we get 133. So to complete that triangle, subtract it from 180, and we end up getting 47. Okay, so not only do the angles in a triangle add up to 180, but the exterior angle and the interior angle together add up to 180. Okay, in the diagram of triangle KLM, angle L measures 70, the measure of angle M is 50, and MK is extended through N. All right, so it's just telling you that's a straight path. Determine the measure of angle LKN. Let's follow that path. LKN. So we got to figure that out. Again, tomorrow I'll show you a shortcut, but for now, we see that we have a triangle. So if I take the 50 and the 70 and add them together, I get 120. All right. And then if I want to figure out what the other angle is, subtract it from 180. So the three angles in our triangle are 70, 50, and 60 because they all add up to 180. But they're not looking for that angle. Oops. They are looking for this outside angle here. And remember, together these form a straight line. So if I do 180 minus 60, it puts me at this angle of 120 degrees. Now you may have noticed that we subtracted 180 and then we subtracted from 180 again. All right, the shortcut I'm going to share with you tomorrow is the two interior angles always add up to equal this exterior angle. All right, so we'll practice more with that tomorrow. Because sometimes you can do it this way, sometimes you can't. You'll have to use that shortcut. All right, last example. All right, we're looking to find the measure of angle ACR, which is out here. Well, we got to get over there first. Well, right here, let's get into the triangle. Got a linear pair, 180 minus 125. To start is 55. And I know by my rules, 60 and 55, this is going to be 115, but let's see why, okay? So 60 and 55, if we add those up, we get 115. And then if we want to find what this angle is in the triangle, we'll subtract it from 180. So that's 65 degrees, right? Because all three angles in the triangle add up to 180. But again, we're looking for that exterior angle. If we do 180 minus 65 again, it's going to put you at that 115 degrees. All right, but again, the shortcut we'll talk more about tomorrow. For now, I want you to do the practice on pages 5 and 6. Classify each triangle by its side and angle measures, so you need at least 2 names for each of these. Find the value of x in each triangle, then classify the triangle based on angle measures, so either acute, obtuse, right. And when you set up the equations, remember the angles in a triangle add up to 180. So set those equal to 180. All right. Page 6, classify by the side lengths. Classify by angle measures. And then at the bottom, just finding the indicated angle measure where the question mark is. And then on this, finding angle M. Start by figuring out what that interior angle at P would have to be. Okay. Good luck. If you have questions, you can ask Mrs. Carbone, and we will go over these at the start of class tomorrow. Have a great day.